Hi, everyone. Now, more on data wrangling. Let us look at handling missing and messy data. Okay. Yeah. So, what we are going to do is, again, we are going to make use of an R code which have been developed, so which is made available. So you can copy from. We are going to look at two parts of it, which is how to detect a missing data. And then also, how then do you handle the missing data? And how to handle the missing data, we're actually going to look at it in two parts, okay? Where part one will be you totally excluding the missing values of the data set. And then part two, using some kind of data imputation, okay? But this particular lecture is just going to focus on the detecting the missing data and then also handling the missing data by excluding all the missing values from the data set, okay? So again, we copy and then paste our code here, and then you can practice along. So first of all, what we're actually going to do is we have intentionally created a vector, okay? So we say X using a concatenate function, 1, 2, NA, and then 4, which we have included a missing value, okay, in the vector. So let us run it, okay? So now we have run it, and then let us look at, we want to ask whether is there NA. If we use is.NA function of our vector, it will actually go into the vector and then look at it. If the value is not NA, it produces false. If it is NA, it produces true. So what you are seeing here, false, false, true, false, tells you that the true over here is the third value in the X variable, okay? Now, we can also sum the number of NA in the vector, okay? This should be X, okay? X. So let's say we use what is called sum is NA function, okay, of what X. So that allows us to know the total number of NAs. So which is what? Only one, okay? And then this one, if you have several columns, you will be able to actually sum the NAs within each of the columns, but we don't have several columns. We only have just a vector, so we will not run this particular part of the code. Now, we can also use a function which is called the complete.cases function, okay? So the complete.cases function actually identify the rows with complete observation, okay? Pretty much similar to the is.NA function. So let us run that, okay? So now what actually happened is the fact that this one, remember, df is not found, so we have to change it to what? X, okay? Because we don't have df, okay? So now it pretty much gives you something similar. So now it is looking at it, okay, so it's 1 NA, it's now looking at only for the complete cases, okay? 1 true, 2 is true, NA, yes, false. So false means it's not a complete case. And then we have 4, which is what? True. So the complete.cases actually give you the true for all the complete cases and false for the missing case, okay? So now let us try to actually apply this on a real data set, okay? So I have a artificially created iris data set, okay, which I have introduced NAs in the data set, you know, in a very haphazard way, you know. So it's making the data look more like it has some number of missing information within the data set. So let's go and grab that data set. So before then, we need the path of the data, which is the iris data. Okay, so let me get that data set. So properties, and then I can copy the path. So first of all, I want to set the working directory. Okay, so the working directory, I'll copy and then paste here, and then change all the backslash to /. Again, some computers may accept the backslash, but for Windows, usually we use the /. Okay, so now the working directory is ready. Let me run it. Okay, so now I'm going to create the data set, which I'm calling it iris_data. You can give it any name you want. So I'm using the read.csv function. That file is a CSV file. Okay, so the array data set is a CSV file data. So with that, we are using read.csv. And then, so we are now calling iris.csv, and it is having column name, so header equal true. Okay, so let's load. So now what it does, it goes into the directory and then pull out the data set. Okay, so this is how it will import it. Okay, so now we can actually look at something like the names. We can use the names of the iris. So iris_data, let us look at it. Okay. Yeah, so there's the name, and then even we can also look at what is the dimension. Okay. Iris_. So what is the dimension? We can now run it. So it's having 150 rows and then 5 columns. Okay. So we can even look at a summary of the data. So iris_. Let's just look at the summaries, what it gives us. So the summary, so you can see with separ length, we are having 13 NAs. We are having a separ with 13 NAs. We are having petal length, 7 NAs. Petal width has no NAs. And then we have the species, which is, of course, it's a categorical variable. So we have to treat it as such. Anyway, so you can also use, so now we can use is.na function of the iris_data. Okay, let's run that line of code. So you can see it's now looking at, so all the NAs is true within each of the columns, and then those that are not NAs are false. But then, I mean, this is not advisable if you have a huge data set. Okay, let's say this has just 150 rows, so we're able to get it. But let's say you have hundreds of thousands of data set, it's not advisable to actually do that. Okay, but you can actually know how many NAs do we have. Okay, so you can use sum and then use the is.na function of the iris_data set. Okay, so use the sum function. So now the number of NAs within the data is 33 NAs. Okay, yeah, so this is how you can actually detect the NAs in the data set, right? So the question now becomes, how do you clean up the data to exclude the NAs? Okay, or how do you handle that missing data or information in your data set? Okay, so there are 2 approaches. One of the approaches is to remove all the missing data of any variable of interest. Okay, and then the second part will be data imputation. Now, this particular lecture, we are looking at only the first part, which is we removing all the missing data, all the missing values or the missing information from the data set. Okay. So what we are going to do is we are going to create a new data set from the original data, but this time we are going to name it clean_iris_data. And then we are going to use na.omit function. So we say na.omit what? So go into the data set, which is the iris_data, and omit every na for all the columns. Okay, so we can go ahead and then run, and then we are assigning that new data set to clean iris clean underscore iris underscore data. Okay, so let's run that line of code. Okay, so now once you have run that line of code, we can just look at the dimension, okay, of the clean iris. So let's look at the dimension. So here the dimension, we now have 117 rows and then 5 columns. So which means 33, which is the missing cases or values, have been excluded from the data set. Okay. So, I mean, you can also just look at it by performing some summary, some summary statistics of the clean data. Okay, so now you can see that now we don't have any missing data given for any of the variables we have. Okay, now you can also use the complete cases, which can actually explicitly filter the rules to include only the cases, only complete cases. Okay, so in the case of complete, so let us in the case we are using the complete.cases function, what we are going to do is, okay, first we are giving it a name, iris underscore complete. Okay, you can choose any name that you deem fit. And then we are going to go to the data set, which is the iris underscore data, which is our original data, okay, which is this original data set, okay. And then what we are going to do is, okay, so we are saying that complete.cases of the iris underscore data, okay, and then for all the, columns, okay. So what we are actually doing is that this one is actually going into each of the rows, okay, and actually give us only complete cases for all the columns, okay. So let's run. Now we can actually give a summary of it, which is here. So you see there is no any missing information. And then we can look at the dimension again, look at the dimension. So this is how you can actually also use the complete cases as a means to extract only the complete cases within the data set. So you can use the na.omit to omit the missing values, or you can use the complete.cases to extract all the complete cases. Okay. Now the question now that arises in some cases, you might not want to actually involve every single variable in the data set, okay? Because there are times you might have so many columns or variables in the data, and some variables may have excessively a lot of missing information, and you don't need that variable anyway for your analysis, okay? So how then do you ensure that you are able to eliminate missing values of only variables of interest without even being concerned about a variable in which you are not interested in? One of the ways in which you can do that is actually make use of the package from the tidyr package. So first of all, you have to install it if you haven't already installed it, but I have already installed it, so I just have to load it, okay? Again, if you haven't installed it, you can use the install the packages functions to install this package. And then once you have installed it, you can just go ahead and load it. And once you have loaded it, now we are actually we are giving it a name, clean underscore iris underscore data 1, okay? And then that's the new data we are actually going to create. We are going to go to the original data sets using this function right here, which is the percentage greater than percentage, okay? And then the function we are actually going to use is drop underscore NA. The drop underscore NA remove all NAs from the data set, okay? That's what it does. So now let us run. So what then it means is that it will remove all the NAs for each of the columns or variables within the data set, okay? It will remove every single row. So it looks at each of the row, and then it looks at for any row that has NA, it will totally remove that row, okay? So let's run it. And then now we can actually run a summary of it, and then you can see we have, okay? Yeah. So this is where the tidyr package become more useful as compared to the other packages where, like I mentioned, you can actually focus on a specific variables and eliminate the missing values, or maybe specific columns and eliminate the missing values without having to eliminate all the missing values for all the column. Remember the first, this code right here eliminated all the missing values within all the columns, okay? But then now we want to only focus on column 1 and column 2, okay, which is sepal length and then petal length, okay? If you actually, let's run this, let's do the summary of the iris data. Okay, so you see the original data we have, this N is for the sepal length and then the sepal width, okay? Now for each of them, we actually want to eliminate the NAs for only those columns, okay? So what we are going to do is, okay, we are naming that new data iris and cleaned underscore iris underscore data 2. And then we are saying that going into the original data, so it is iris underscore data, using again this function, we use the drop underscore NA, and then we are taking column 1 and 2, okay? Because column 1 and 2 have the iris, the sepal length, and then sepal width, okay? We are only focusing on column 1 and 2. So once we can go ahead and run it, and then now we can actually give a summary of it. Now you can see in summary, column 1 and 2 NAs have been removed, or missing values have been removed, but column 3 still have, or variable 3 still have NAs. Why? Because we didn't ask for NAs to be removed from the third variable, okay? So this is how actually useful the tidyr allow you to actually specifically select variables in which you're actually interested in removing the NAs without having to remove NAs for the entire data set, okay? Because there are instances in which your data set can have a lot of NAs for a specific variable in which it is not of interest. So if you end up eliminating all NAs for that particular variable, you end up reducing your data set drastically, and you wouldn't want that to happen, because if you are performing analysis, the bigger your data, the better or the robust your analysis can be, okay? So this is how you can actually detect NAs and also remove and detect missing data, and also remove missing data or missing values from your data set, okay? So in the next lecture, we actually look at how do you actually use a different method. Rather than removing the missing data, we can actually use what is called a data imputation, okay? So I will see you in that lecture.